This video, we're going to walk through how to analyze two sets of data from two different surveys using Excel's data analysis tool. The first survey looks at the midterm grades of students from two different sections. The goal is to determine if there's a significant relationship or difference between their performances. The second survey compares the first and second term GWA of students from a single section to see if their academic performance has improved.
Let's now dive into the first analysis. For this dataset, we have the midterm grades of sections MAR 242 and MAR 243. Our goal is to determine whether there is a significant difference in their academic performance. To do this, we'll use Excel's t-test to sample assuming equal variances. Let's first state our hypothesis. Our null hypothesis is there is no significant difference between the midterm grades of MAR 242 and 243. Our alternative hypothesis is there is a significant difference between the midterm grades of MAR 242 and MAR 243. We'll use a significance level or alpha of 0.05, and since we're testing for any difference, it will be a two-tailed test. Now, let's perform the analysis in Excel. First, go to the Data tab and click on Data Analysis on the far right. From the list of tools, choose t-test to sample assuming equal variances, then click OK. For variable 1, highlight the data from MAR 242, including the column title. For variable 2, do the same with the data from MAR 243. Set the hypothesized mean difference to 0 and the alpha to 0.05. You can leave the output options as is, then press OK. Excel will now generate the results on a new sheet. Since we're using a two-tailed test, we will look at the p-two-tail value. Let's now interpret the results. If the p-value is greater than 0.05, we fail to reject the null hypothesis. That means there's no significant difference between the midterm grades of both sections. In this case, our p-value is greater than 0.05, so our conclusion is to not reject HO. Therefore, we can say that the midterm grades of both sections are not significantly different.
Let's move on to the second analysis. This time, we're working with the first and second term GWA of students from section MAR 242. Our goal is to determine whether there is a significant improvement in their academic performance from the first to the second term. Since we are comparing two sets of related scores from the same students, we'll use a paired t-test in Excel. Let's first state our hypothesis. Null hypothesis. There is no significant increase in the academic performance of MAR 242 students from the first term to the second term. Alternative hypothesis. There is a significant increase in their academic performance in the second term. We'll use a significance level alpha of 0.01, and because we are only interested in checking for an increase, this will be a one-tailed test.
Now, let's do the analysis in Excel. First, go to the Data tab and click on Data Analysis. Select Paired 2 Sample for means and click OK. After, for variable number 1, highlight the GWA data for the first term, including the label. Then for variable number 2, highlight the GWA data for the second term. Then set the hypothesized mean difference to 0 and the alpha to 0.01. Lastly, choose an output range or let Excel open a new sheet and then press OK. Once Excel generates the output, we'll look at the probability that t is less than or equal to t one-tailed value since we are conducting a one-tailed test. Let us now interpret the result. In this case, our p-value is 0.44. which is greater than our alpha of 0.01. So, we fail to reject the null hypothesis.
To recap, here are the steps in analyzing data using Excel. First, go to the Data tab and click on Data Analysis. Make sure the Analysis Toolpak is enabled. Second, select the appropriate statistical test, t-test, ANOVA, regression, based on your research question and data type. Third, input the data range for your variables in the dialog box and specify if your data has tables. Next, set your alpha significance level in the input box provided. Then choose the hypothesis type, one-tailed or two-tailed, depending on the direction or your research question. Run the analysis and examining the results, focusing on the p-value or test statistic. Compare the p-value to your alpha. Draw a conclusion based on the result and interpret it in the context of your research. These examples show how we can use simple tools like Excel to extract meaningful insights from data, helping us make informed academic or administrative decisions. Thanks for watching. I hope you enjoyed the video.